This will actually be good because now we can see. Is she back tomorrow? I think she's back tomorrow. Okay. So we can see if she actually watched the video. See if she knows this. Because Riley, I'm sorry we forgot. The first 20 minutes, but you probably don't absolutely need that anyway. So you're welcome. I shortened the video for you. All right. So here we go. So the question I asked you on that test was this. In this scenario, is the K positive or negative? Remember that? And what was the answer? It was negative. Why?
Because the Y represents the temperature of the coffee, and it has to be greater than the temperature of the room, so that value would be positive.
So there were two parts to this, right? First one, Nick's right on. Why is the temperature of the coffee? It was hotter than the room, which is what T was. T was the room temperature. So therefore, this has to be a positive value. That was the first part. What else? There was a second part to it. What's, yeah. Riley, it's okay, Riley. Just listen to what I'm saying. All right. But we were gone for 2 weeks. I know. I kind of forgot what. All right. So. No, we should all meet here tomorrow at 7 so we can all get back in the swing. All right. So Riley, here is Newton's law of cooling. I'm gonna really be mad now if she doesn't watch it. All right. So that is positive. Okay. What else do we need to talk about here, Tim?
The Y prime represents the change in temperature.
And the temperature is
Decreasing.
so according to the chart, if Y is decreasing, Y prime has to be negative. So on the quiz, to get those points, you had to do both of those things. So if that's negative and that's positive, then K has to be negative, right? And sometimes in these differential equations, they'll just stick negative on K, so you just really emphasize the fact that that's negative, which of course then means K would be positive, okay? So that was our introduction to that earlier, this equation, but we didn't really do anything with it. Well, now we're going to add this to our list of differential equations. We're going to memorize the solution. Now, we could do a slope field on our calculators of this, right? We could type this in, and if we had some numbers to put in for T and for K, right? But we're going to actually just tell you what the solution is for this, okay? And you're going to have to memorize this. Now, it's very much like the bank interest problem. Okay? What do you suppose the graph of the temperature looks like? I mean, you got hot coffee, so the temperature starts out up here high, and it's cooling. So it's got to go down, right? Well, what's going to happen as it gets close to room temperature? It's going to level off, kind of like the one we were just looking at, that thing with terminal velocity a little bit, right? It's going to level off at room temperature. So it's going to have the look of an exponential function. All right, the difference is K would be negative in this case as opposed to bank interest where the K is positive and the growth rate is positive. Okay, and it turns out that looks very much like the bank interest problem. It's capital T plus AE to the KT. That is the solution to Newton's law of cooling. And that is the equation you're going to spend most of your time working with. And that is the equation you will need to memorize for the quiz if you get a problem involving a liquid that's cooling or any object that is cooling. All right? So that's what we work with. Now, of all those letters there, what's the input variable? Little t, right? And the output variable is y. Now, of course, we can see that right here where it says dy dt. The dt tells us that the input variable is t with respect to t. Okay? The capital T is, that's the surrounding temperature, the air temperature surrounding the object. Okay? So that's a constant. We'll call that a constant. Okay? A is just some other constant, right, that's involved depending on the initial conditions. And then K is another constant, and K in this case comes from the properties of the particular thing that's cooling, maybe the chemical properties. It could also involve the cup that it's in, right? A styrofoam cup, it's going to keep it warmer compared to say just a paper cup or a ceramic mug or something like that, right? So the K takes into account those properties or those things in the problem. Okay, so those are just constants that you find. All right, so let's just do an example scenario, which would be something like this. You've got a cup of liquid in a room. Its initial temperature is 180 degrees. After 3 minutes, it's 160 degrees. And by the way, the room is 65 degrees. What temperature is the coffee after 5 minutes? That's the problem that we're talking about. So let's take all that information and write it down in mathematical terms. So what was the first thing? It starts out 180 degrees. What is that? What would be a way to write that mathematically? It could. It's in physics class if I'm in. But our temperature is not T though in this problem. It's what? It's Y, right? So that could be Y initial. Or if we want to use function notation like we've mostly done, I'd write it what? Y of 0. Okay. So my goal is that everybody would think right away to write that Y of 0 equals 180. I have not achieved my goal yet, but I'm going to before the year's over. So you would write Y of 0 equals 180. Okay, what other piece of information did I give you? Y of 3 equals 160. And we wanted, and I asked you for Y of 5. And I also gave you the room temp, which is, so I also told you the big T was 65. Okay, with that information, we should be able to find what we need. We don't know A and we don't know K, but we have 2 initial conditions. If you have 2 initial conditions, you should be able to find 2 unknown. Right? It's like 2 equations, 2 unknown. So where do I start? Right, into my solution. This is what I want. So zero is always a good one to start with, right? So let's put that first one in. So we put what in for Y? 180 equals 65. A K times 0. K times 0, of course, is 0. Even 0 is 1. So 65 plus A would equal 180. So A would equal 115. Okay, now what? Put it to 115. Probably should just rewrite the equation at this point. Yeah, I think the best thing would be to rewrite my equation, except this time with the 115 in there for A. Right? So now my equation is that, but I don't know what K is. So plug in the next piece of information, the 160. And K I don't know, and T this time is 3. Now, somebody in the other class wrote that K3. I probably should write 3K. You got to be careful on your calculator though. 3K, the calculator will understand 3 times K. If you put K3, it'll think it's a variable, like X1, Y1, X2, Y2. It'll think K3 is a variable. It won't think that that's times. You have to put K times 3. Okay? So just a word of caution. All right? Now what? Solve for K. So how do I solve for K? Good. Was anybody sitting there thinking, grab my calculator and go algebra, solve? You should have, because you'll be able to do that. This will be a calculator problem. So you will be allowed to solve this on your calculator. But let's go ahead and do, before we do that, let's go ahead and do what you were just saying, which is subtract the 65, which makes 95, equals 115, e to the 3K. Because on the AP test, on our midterm, there will probably be some problems in multiple choice especially where there's no calculator and you will have to solve an exponential, okay? So we need to be able to do this. So we subtract that over, divide by 115, that'll probably reduce. You would probably need to reduce that on the, you know, to do a multiple choice problem. Do ln on both sides, right? Remember this was Appendix E the first week of class. We worked on this. That's 3K. Then divide by 3, or I would prefer to put a 1/3 out there. And then let's see, let's reduce 95 over 115. 5 is doing both of those. 19, right? 5 times 20 is 100. Well, you're 1 5 short of 100, so that'd be 19. And here you're what? 3 5s over 100? So that'd be 23. 19 23rds equals K. All right. Now let's Carrie, go to your go to the calculator here, and just type this in first. Do 1/3 times ln of 19 23rds, and hit Control Enter to give us a decimal. Well, that's interesting. You hit Control Enter, so it'll give us an approximate. So that's fine. Actually, I'm glad you did. Look at this. Isn't that weird? Look what it did with that ln. It flipped it to make it and then a -1 power. And what can you do with an ln with a power?
Move it out to 1 front.
Bring the power out in front. So see what they did? They flipped that. They made it a -1 power, and then brought the negative power out in front. Which is, I don't know why you would do that. That's great. There must be some rule there. It wants an improper fraction. I don't know. Strange. But it's -0.063. And I would take, if we're going to do a decimal, I would take several places. So let's go 685. Let's go 6 places. So -0.063685. That's our K value. Remember, we said it should be negative, and it is. Okay? So you'll go through, and now we found our K value. So now we've got our entire equation. Y equals 65 plus 115 e to the -0.063685 T. That is the temperature of our coffee. Now, let's go ahead just for the heck of it here and run through this as review. Do a solve, Carrie, for us. So we could have on the quiz, if you have a problem like this, I want to see some of this work. But once you get to this step right here, it's okay. Matter of fact, I don't really care. I mean, if you can do this in your head, the 65 minus 180, the 115, if you can do a bunch of that in your head, that's fine. I mean, you don't have to write it all down. But this equation, if you're going to solve this equation on your calculator, you need to write this equation down. And so now we go here, we go to solve. She's got it going here. And then you can put. No, wait a minute. We didn't know that yet. Wait a minute. What are you doing here? Back up. See, I'm glad we're reviewing this. This is good.
Sorry, I don't remember this.
Well, what we're doing is we're solving this equation right here.
Oh.
This is the equation we're solving.
Oh.
So put a 160 in there instead of the x. Yeah. So, and I confused you because I went ahead and did all this. What we would have done is we would have written this and we said, hey, I need to solve that for k. And so we would have typed it in. Okay, and so we'd have had, and here's where, and you can use k or you can use x, you can use whatever. Okay, and that's good. If you make it 3x, and then you don't have that mistake that Jake and Veronica made when he went x3 or k3. Now, what'd she forget? Oops. Well, no, she didn't forget it. She just put it in the wrong place. It's got to be in the parentheses. What is it that goes out of the parentheses that she was thinking of? Your limits, your restraints, the vertical bar, that stuff. Okay, and sure enough, there's our same answer. Okay, same answer. So we could have saved ourselves all this, but we just could have done that. All right, now what's left?
Substitute the y value of 5 in for T.
The 5. Substitute 5 in for T. So how hot is the coffee at now after 5 minutes? So go ahead and just type that in and just put a 5 right there for the T. Okay? And while she's doing that, the other question I could have asked there would have been, instead of saying, how hot's the coffee after 5 minutes, I could have said, how long does it take the coffee to get down to 120 degrees? What would have been different there? You just put the 120 in for the Y and solve for T. There you'd have had to do a solve thing. Here she's not going to have to do a solve, I don't think, is she? Yeah, she's not going to have to do a solve here. She's just going to type this in with the 5 right there. She won't even need a solve, right? It's just evaluating that expression. But if we would have said, how long does it take the coffee to get down to 120, we'd have put a 120 there, and we'd want to find T. Well, then we do have to do a solve. Okay, so after 5 minutes, the coffee's down to 148.639 degrees. So that's Newton's law of cooling. It's a differential equation, but really, if you memorize the solution, there really is no calculus in this, right? The only calculus in this question is understanding that a Newton's law of cooling problem comes from this differential equation. But once you know its solution is this, I mean, this is nothing but a plugging in numbers to a function and solving an equation. I mean, that's all that. Okay? I mean, but there's value in that, and so we want to make sure we can do that. Okay, so that's going to be in your homework. All right, that is almost it. Okay? I thought about buying you something at Qdoba. Almost it. All right. That's an inside joke. All right, so, oh. All right, one last thing. All right, one last problem. Write this down. Try a little different approach than I took with second block, because they just couldn't do it with the approach I tried. So this one. This is good. There's some questions like this in your homework. All right. So I gave you a differential equation. I actually gave you an initial value problem, right? Differential equation with an initial condition. Find the equation of tangent line. I should say the equation of the tangent line to the y graph. Okay. At t equals 0. Okay? All right? Go. Give me a couple minutes to do that. Okay, you should be done. Is anybody done? What? You would have thrived at the other. Well, the other approach really wasn't any different. I didn't tell them anything either, but they started working on the homework. Why are you doing this? So I thought we'd try it this way. Worded a little bit. Actually less confusing, I thought. But this was supposed to be the smart class, right? No, come on. Over and over, and I have to say this over and over again, and I have to do it every year. One of these years, I'm not going to have to, but I don't know what it is about these problems. Finding the equation of the tangent line. How do you find the equation of the tangent line? You need a slope and a point. And you put that into the point slope form. And so you need a point. Do we have a point?
Yes.
Yes. Is there any way with the information up there we can find a slope?
Yes.
Oh, it's y prime. How would we find the slope?
Y prime
We
equals
put a 0 there,
0 squared minus 3.
minus 3. So the slope's negative 3. So the point slope form says y equals,
Negative 3, parentheses, x minus x point is 0. And then plus 3.
so was I crazy to think that that should have been easy? Okay. All right. But, you know, again, it's this process of repetition. It's one of the reasons that we end up doing pretty well when we get to the AP test, but we do lousy at this point, right? But it's a process in getting there, and eventually you have to see things and practice things a number of times, and many more times than you want to see them, until they start to soak in, right? But finding the equation of a tangent line means you need a point, you need a slope. The only thing that's been different as we've went through the year, they haven't all been the same question, have they? They have been the same question, but they haven't been. They're always the same in the sense that you need a point, you need a slope, and you need to put it into the point slope form. The difference is we've had a whole variety of ways to find the slope. In the early stages in chapter 1, I gave you an F prime graph, and you found the slope from there. In chapter 3, when we were learning the derivative rules, I gave you a y equation, and you had to do a derivative rule to get the y prime, and then you found the slope from there. Here, I've given you a differential equation. But again, a differential equation gives you slope, right? So it's just giving you a variety of ways of finding slope. So anyway, that is all you do. Now, on the homework questions, I think it says something like verify or explain that this is the equation of the tangent line. I just think your work is your explanation. Just find the equation of the tangent line and say, oh yeah, there it is. That's it. Okay, so your homework is the next line on that 4.1, okay? Well, actually the top line on the 4.1 assignment. Problems 3, 4, 5, and 6 are like the one we just did, okay? Equation of tangent line kind of thing. Then 7 through 14 is matching. Now, I'm okay if you just want to do the matching like in your head, not the matching, but the second part. On 7 through 14 it says match the graph with the differential equation. So you got to do that. And then it says draw the solution curve through the blue dots. Now, how do you do that without drawing in the book? Now, somebody maybe already has. If you look in the book, probably somebody's already drawn in there. You could lay your paper over top of the book and kind of trace through it. Or if you want to, just understand that when it comes to the quiz, you're going to have to be able to do this. All right? So you're going to have to be able, okay, for this initial condition, the solution curve would come up through here and level off, and then come down through here and level off, and that'd be the solution curve. So if you just look at them and kind of can tell where it would be, that's good enough. You don't have to do it on the homework. Okay, I won't look for the graphs. You can just do the matching. But understand you'll have to do that. Now, if you were doing this initial condition up here, it would just be a matter of kind of coming down and leveling, and then just, it looks like it's going to kind of level again, but you can't really tell, so you just stop right there. Okay? And then likewise with this one. So that's what those blue dots are in there for. All right, and then 23, if you turn to page 23 and 24 are both Newton's law of cooling, which is like the one we just got into. All right, 23's got multiple parts, so it does take a little bit of time, but that's okay. I guarantee you there will be a problem like 23 or 24 on the next quiz, or like the one we just did up here, a Newton's law of cooling. Guaranteed. Yes. Friday, but more likely Monday. Possibly Friday, but more likely Monday. I'll know more by about, what's tomorrow? Wednesday. I'll know for sure on Thursday. All right, rest of the time is yours to work.